are measured in the same units. Question, cm and meters, are they the same unit? Cm and meter, same unit or? Different units, but they are both units used for measuring length, but they are different units. Okay, so ratio must be same unit. Next, a ratio has no units. When the units are the same, we can conveniently remove them already. Later on, I will be showing you that ratio is actually very similar to fraction. Okay, where we cancel the same factor, likewise we can cancel the same unit. Okay, the ratio of A and B can be written as A colon B. Okay, no surprises over there. Now, this is the next one I need you to know. The ratio can also be written as A over B. Okay, important over here. Just as I say, ratio of A to B means you must write A first, and then you write B in a fraction form. When I say A to B, A must be in the numerator, B must be in the denominator. The order matters greatly. Okay, now next, some examples of equivalent ratios are, for example, 15 to 3 and 5 to 1. 1 to 1 to 22 and 11 to 2, so on and so forth. I'm sure you can come up with your own examples. These are just examples. Okay, then we also notice that, hey, we can also use decimals. 4.2 to 0.7 can also be written as 6 to 1. Okay, then we have a ratio in simplest form. Okay, now this is where I need you to do some exercises. Ratio in the simplest form. Let's start with the first one, 13 to 39. What will you do? 1 over. 1 is to, so right now 1 is to 3. Okay, I just want to confirm your thought process. How did you get 1 is to 3? Divide by 13 on both sides, right? You find the common factor, you divide. Okay, what about the next one? What can you divide by? Divide by 2? 3? 6? Divide by 6. Okay, let's see what happens when we divide by 6. We get 4 is to 7. Right? Now, if you did not divide by 6, if you had divided by, for example, 2, you get 12 is to 21. Then you realize that, hey, I can divide by 3 again. And then you get 4 is to 7, eh? Yeah, okay, divide by 6, so 4 is to 7. Okay? Then we go on to decimal. Okay, how are you going to deal with decimal this time? What will you do? How? 1.8 to 0.4. Yes. Pretend that the decimal is not there. So, times 10. Okay, times 10 we get 18 to 4. And then what do you do? Divide by 2. 9 is to 2. Okay, can. What about part D? Do they have the same units? No. Units not the same, so you must convert them to the same unit. Do you want to convert cents to dollar or dollar to cent? Dollar to cent. I think most would change dollar to cent. Okay, so let's do that. 35 cents to 200 cents. Now that the units are the same, I can remove the units. And what do we have? Divide by 7. So we get 5. Divide by 5, you get 7 to 40. 7 to 40. Okay. I think you can do the rest. And now, I am going to show you a shortcut. Calculator. You know how to use it? Yes. Okay, so I show you. Look. In your calculator, 13 to 39. Like I say, the ratio can be written as a fraction. So 13 to 39, numerator is 13. Denominator is 39. So I key in a fraction, which you can't really see. How to switch on this light? Okay, 13 to 39. You press equal. Tada, 1 is to 3. Okay, and that is our answer, 1 is to 3. 1 is to 3. Okay, next one. So 24 to 42. Let's key in the numerator. 24. 24 to 42. And you get 4 is to 7. 4 is to 7. Okay? So it saves you a lot of time. It works for a fraction, it works for decimals. But important thing is that you must change them to the same unit. But there is one case, or rather two cases, that I can think of where this calculator cannot be used. Where is it? Part H. When you have three ratios over there, you cannot use your calculator. Yes?
I did use calculator. So just fraction two, like two of them, like first two, last two,
So you fraction the first two, fraction the last two, then you fraction the first and the last. Okay, a bit complicated lah. So yes, it can work. Alternatively, just go back to your basics. Okay, so for this, you just multiply throughout, and this will be your homework. Okay, this line is your homework. I'm sure you can do it. Okay, next one. Example number 2. $248 is divided among 3 girls in a ratio half to 1/5 to 1/3. Okay, now express the ratio in its lowest term. Give me your answer in the form x to y to z. When we talk about the lowest term, we are expecting integers only. No fraction, no decimal. And you reduce them, you remove all the common factors. So let's start with the first one, part A. How do we find the equivalent ratio 1 to 5 to 3? So we want to multiply all of them by a certain number such that we will remove all the fraction. At the same time, the number that I want to multiply, I should have it as small as possible, so that eventually I don't need to reduce them any further, so that I don't need to simplify. So in order to do that, we're going to search for the LCM of 2, 5, and 3, which gives us, is it 30? 30. Okay, this is the LCM. So I am going to multiply by 30 for every single one of them to give me 15 to 6 to 10. 15 to 6 to 10. And this is my equivalent ratio. Okay? So for your fractions, you just need to multiply by the LCM of the denominator. Then you will be able to get the final ratio in the simplest form. And then in part B, find the amount of the largest share. This is not very useful as a ratio, but 15 to 6 to 10, that is more manageable. The largest share is 15 units. 15 units out of 15 plus 6 plus 10 units. Okay, so you can write it down as, I show you two ways of presenting. The first way of presenting is largest share is equal to 15 units out of 15 plus 6 plus 10. Because now this is the fraction. 15 out of the total. Okay, then you multiply this by the entire sum, which is 248. 248. And you get the answer. So 15 divided by 2131. Okay, times 248. And we get $120. This is one way you can present for the largest share. 15 units out of the total number of units. But you notice that I don't draw things like arrow. I don't write things like U for unit. I don't even write units. Okay? In this first presentation. Now the other presentation could be something that you'll find familiar. So just put it in black on the right hand side for part B. You can say things like 15 plus 6 plus 10 units. Okay, this is where units come in. Represent $248. 248, yeah, correct? I did not write equal. I did not draw arrow. I did not put a dash. I wrote REP. That is the only thing I'm going to accept. Okay, I say again. No arrows, no dashes, no equal sign. REP for represent. So this is our 31 units represent 248. Therefore, my largest will be 15 units. Will now represent. So we do a division to give us 248 divided by 31, and then we do a multiplication times 15. You get the same answer of $120. So this is the other presentation that I will accept. Notice that in this case, I did not bother finding 1 unit. Yeah, you can do that. 1 unit represent 248 divided by 31. Then after that, you're still going to have to multiply by 15. So we can skip that step if we have the following structure. The number of units represent the money. Okay, then you always work this way, as long as it's a direct proportion. Any questions? Okay, then I think it's quite easy to you lah. Okay, so let's go on to example number 3. X to y, 1 1/4 to 2/3. Okay, x to z, 1 3/7, 5, 6, find x, y, z. So we're going to write this way, x to y to z. This is my presentation. We're going to eventually combine all 3 ratios, all 3 quantities together in one single ratio. So let's start with what we know first. 1 1/4, which is 5/4 to 2/3. Okay, 5/4 to 2/3. So I want it in its simplest form. I want to remove the fraction. Therefore, I have to multiply by a certain number such that I remove the fraction. And what is the LCM of 4 and 3? Well, so multiply by 12 on both sides. This will result in the simplest form. So you multiply by 12, we get 15, 2, and on the other side, 8. 15 to 8. Right, that is for the first pair of fraction. And then now we have x to z. X to z is 1 and 3/7. This time to z, 5/6. So 1 and 3/7, let's just quickly convert that it becomes 10/7. Okay, a little lack of space now. So this is my x to z. And what is the LCM of 7 and 6? 42. 42. So let us multiply by 42 on both sides. Due to a lack of space, I'm going to just erase it. Okay, but for you, try and write it neatly. Okay, so multiplying by 42 on both sides, I get 60. So this results in 60. Then I multiply by 42 on this side, I get 35. Okay? Anybody lost so far? I'm not done yet. Anybody lost already? You can follow up. All I did was to just rewrite both fractions, both ratios in the same presentation of x to y to z. But follow the column. Okay, now I've got x to y by itself. I've got x to z by itself. To combine them, what is the common term in this case? Is it the x or the y or the z that is common? The x is common. Since the x is common, we just focus on x. I want to make 15 become 60. Either that or I make 60 become 15. One will be better than the other. So clearly, we want to change the 15 to become 60 to find its equivalent form. What should we multiply 15 to get 60? So here we multiply by how much? 4, right? So you multiply by 4, then for your 8, you also multiply by 4, and you get 32. So this is now our ratio, 60, 32, 35. And it will be the simplest form. Okay? If you cannot do all this in one presentation like this, go ahead and separate them. But make sure you are neat in your work. Okay, so 60, 32, 35. Any questions? You haven't seen this type of question in primary school, right? Or have? Have? Okay, some have, some don't. Okay, different primary school. Okay, so moving on to example number 4. Amanda is 18 years old. Bervin is 3 years younger than her. Find the ratio. Okay, wow, this is so simple. But presentation, this is what I want to see. Amanda to Bervin. Amanda to Bervin. So Amanda is 18. Bervin is 3 years younger than her, so 15. And then you reduce the ratio, dividing by 3 on both sides, you get 6 to 5. Do you hear me repeating a common phrase? you do the same thing on both sides. For the equal sign, you minus one side, you minus the other side. In this case, our ratio, you do the same on both sides also. Both sides divided by 3. And that's the answer. Okay, now, in a chess club, ratio number of boys to girls, 7 to 4. Presentation, boys to girls. Okay, you can spell it out. B to G is fine also. 7 to 4. Given that there are 56 boys, so this is 56, and what is this value? Find the number of girls. How do we decide? What if your times table is not good? 56 divided by 7, then you get 8, isn't it? So you multiply by 8, likewise multiply by 8, and you get 32. Okay, so just write there are 32 girls. Simple. Am I going too fast? Alright, then Pauline took 3 papers in the maths test. The test results were 3 to 5 to 2. The highest was 85 marks. Find the lowest mark that she scored. Okay, in order to do this, actually do you realize that there is some redundant information? There's actually a piece of information that we did not need to use. Okay, so in this case, 3 to 5 to 2, those are lowest form representing the score. The highest mark was 85. So that tells us which of this is our 85. So the 5 over there, represented by 5 units, represent 85 marks. This is not the only acceptable presentation. Next, they want to find the lowest. So 2 units represent 85 over 5. So this is what I always do. Divide, then multiply. Then you multiply this by 2. And we get 1, 7, 34. 34 marks. Yes? Yeah, there is one more test. That's why I say it's a redundant information. This 3 was not used at all. Okay, they didn't ask us to find the middle mark that she scored. So now it's just useless information. Ignore it. Okay, then now I want you to try example number 7 by yourself. Example 7. Okay, next, A to B. To B, we have 3 to 4. Then we have B to C, which is 2 to 5. Now B is the B term is common. Okay, the B term is common. I need to change my 2 to 5 to become 4 to 10. So in summary, I have 3 to 4 to 10. So that is our example 7. Okay, I think you can do all these by yourself. I want to do example number 10. I want you to try example number 10 yourself. Example 8 and 9, both your homework. You all no lesson tomorrow, right? Yeah, okay. So I won't be seeing you all tomorrow, not Friday, Monday, Tuesday, so a lot of days to do homework. Okay, example number 10. I want you to try this now. 2x equal to 3y. What is the ratio of x to y? The answer is given to you. I want to see how you're going to present it. Anybody started off by writing this? 2x to 3y. Anybody? Poland. Anybody? Wrong already. They didn't say 2x equal. They didn't say 2x to 3y. They said 2x equals to 3y. So this is wrong, Okay, now remember our ratio can be written as fraction. If they want x to y, if this is what they want, then in your mind, okay, at the end of the day, if I can write x over y equals to a number over another number, then I know the ratio of x to y must be the first number, numerator to denominator. So the question is, are you able to write this fraction, x over y? Turns out it's super easy to do so. 2x equals to 3y, x equals to 3 over 2y, x over y equals to 3 over 2. Do you agree? We are just making, you all cannot see, never say. We are just making x over y the subject. Because the moment I have the fraction of x over y, it means I have the ratio x is to y. Right? So in this case, x over y is 3 over 2. Therefore, x to y is 3 is to 2. Okay, got it correct, but do you know how to explain? Okay, so, yeah, so this is your homework. Is it too much?